Hi, my name is Kaylee Vickery, and today we are going to be doing a pH chemistry experiment. I chose Standard 2 Physical Science. The student will increase their understanding of the properties of objects and materials that they encounter on a daily basis. The student will compare, describe, sort, and classify these materials by observable properties. Benchmark I chose was number 1. The student will develop skills to describe objects. Indicator number 3 observes and records how one object interacts with another object. And the objective for today's experiment is the student will be able to classify the pH of household items accurately, recording 7 out of 7 in their data table. And the level this is 5th grade. Today, since we're doing a mini experiment, we're only going to be using 4 variables. We're going to be using pine salt, milk, lemon juice, and Windex. And the students are going to be using what I created as an indicator, which is a cabbage juice indicator. The preparation I did ahead of time to make the cabbage juice indicator. For the engage stage, before we start the lesson, I will just ask the students what they know about pH already and how we might test for pH in various household liquids. For the explore stage, that's the stage we're going to be actually completing today. After we do our explore stage, we will be doing the explain stage, which is where I will encourage the students to discuss the results and their procedures with how they completed the experiment with the rest of the class. Some of the students that I might some of the questions that I might ask the students are: which household cleaners or beverages had a pH of less than 7? Which ones had a pH of more than 7? And which ones had a pH of exactly 7? And if they had, in what color the liquid changed after they put the variable into the indicator, and what color it was, if it was more than 7, exactly 7, or less than 7. One of the ways that we might, that I might put this in as a real-world experiment would be to explain to the students that overall the pH in foods, liquids, the soil, or the human body, it's important for the overall structure and the function of the enzymes in the living systems. And in agriculture, the balancing of pH is important for the soil. Because if it's less or more or too much, it will affect the growth of the crops and it could kill the crops. The elaborate stage, I'll ask the students if they think that the temperature might affect the overall outcome of the readability, and the temperature I'm referring to is the temperature of the indicator, and how might we design an experiment to test this variable. And in order to do the elaborate stage, we will basically be redoing the experiment, and we'll be using 3 indicators. They'll all be cabbage indicators, only the first one will be, the temperature will be 0 degrees Celsius, the second one will be 25 degrees Celsius, and the third one will be 50 degrees Celsius. And we will use the results to record them on our data table and compare them to how the indicator at room temperature and the 3 different indicators at the 3 different temperatures might have affected our overall results. And for the evaluate stage, to check for the understanding, the students are going to be using their science journals, and they're going to be writing. There's 3 questions that they're going to be answering. The first one is, which of the household liquids contained a pH of more than 7? And what was your evidence? And how could you tell that it had more than 7? And did some household liquids contain less than 7? And when you initially thought that they might have been more than 7. So now we're going to go ahead and start our experiment. They are going to be putting the variable into each one of these are the variables in the small ones, and this is the cabbage indicator in the tall ones. And they're going to be dumping a small portion of the variable into the indicator until the indicator starts to change colors. Once the indicator changes colors, they're going to stop. They're going to stir it around to make sure it's evenly spread throughout the liquid. And then they're going to take their pH strip, their test strip, dip it in, and wait 15 seconds, approximately 15 seconds. Then on their data collection sheet right here, next to whichever variable they just tested, they're going to be writing down what color the pH strip changed to, and on the pH scale that I have right here, they are going to be recording what the number was. So if you guys would like to go ahead and start, I'll leave that right there so you can use it. Ooh. For technology, I could integrate technology into this lesson by having the students complete a graph that graphs their results. They can use the computer. For my experiment, I used a graph on Microsoft Word and graphed the acid, the neutral, and the alkaline of my results. So the students could do that, or we could complete they could do that in the small groups, because they're going to be working in small groups of 3 to 4 depending on the class size. So they could do an individual small group results graph on their computer, or we could do a graph as a whole and use the smartboard to record our results on it. And for any students that might have like a fine motor skill disability, they could, instead of being the one who actually maybe dips it in, they could be the one that pours it in, or they could be the one that records the results. Right now they're just waiting to see if they wait for the test results on the strip. What'd you guys get for milk? What was the color?
7, and it was green.
Ooh. Which makes it what? An acid, alkaline, or neutral?
Neutral.
Good job. And then the last one. What's the last one?
Pencil.
I'd say it's about 13, 12, 13. So that makes it what?
Alkaline.
An alkaline. Alright, and there you have it. There's our experiment.